Hello friends, welcome. Myself Soumya, Assistant Professor, Department of Mathematics, Government First Grade College, Tiptur. So in this session, we shall deal with the intervals, open interval, closed interval, neighborhood of a point, open intervals, closed interval, and neighborhood of a points, and theorems on the neighborhood. The definition of a closed interval: the set X such that X belongs to R and X lies between A and B, or we can say A less than or equal to X, X less than or equal to B, is called a closed interval, and it is denoted by the square brackets A and B inside the square brackets. So A and B are called the endpoints of the interval. So in the closed interval, we take the points between A and B, including the points A and the point B. So that is the closed interval. So next we have the definition of open interval: the set X such that X belongs to R, X lies between A and B. X lies strictly between A and B is called an open interval and is denoted by the small A and B in between the small brackets. So here we consider the points between A and B excluding A and B. We don't consider the point A and B. So that is the open interval. And the neighborhood of a point. The definition of neighborhood of a point: a subset N of R is called a neighborhood of a point P if there exists an open interval I containing P and itself containing in N. So that is called the neighborhood of a point. So theorem, here we have the theorem: prove that any superset of the neighborhood of a point is also a neighborhood of that point. So any superset of the neighborhood of a point is also a neighborhood of the same point. So let us have the proof. Let N be the neighborhood of a point X, then there exists epsilon positive such that X minus epsilon, X plus epsilon is a subset of N. If M is a superset of N, then N is a subset of M. M is the superset of N, therefore N is a subset of M, or M contains N into X minus epsilon, X plus epsilon, which is a subset of N, and N is again a subset of M into X minus the real number X minus epsilon, X plus epsilon, which is again a subset of M. Therefore we can say that M is also a neighborhood of the point X. And the next theorem: prove that intersection of any two neighborhood of a point X is again a neighborhood of the point X. It is similar to the previous theorem. So let us have the proof. Let N1 and N2 be the two neighborhood of the point X. Then there exists epsilon 1 positive and epsilon 2 positive such that X minus epsilon 1, X plus epsilon 1 is a subset of N1, and the real number X minus epsilon 2, X plus epsilon 2 is a subset of N2. So let epsilon be the minimum of epsilon 1 and epsilon 2. Then the real number or the interval X minus epsilon, X plus epsilon is a subset of X minus epsilon 1, X plus epsilon 1, which is a subset of N1 into X minus epsilon 1 plus X plus epsilon 1, which is again a subset of X minus epsilon 2, X plus epsilon 2, and that is a subset of N2 into X minus epsilon 1, X plus epsilon, which is a subset of N1 intersection N2. Therefore we can say that N1 intersection N2 is a neighborhood of the point X. And the short answers you can define from this session. You are able to define the neighborhood of a point and give an example of a set which is not a neighborhood of any of its point. You can think of this question. And the descriptive session questions here is for you: if M is a neighborhood of the point and N is contained in M, then N is also a neighborhood of the point X. And the second question for you is: if M and N are neighborhood of a point X, then M intersection N is also a neighborhood of X. The references: Real Analysis, N.P. Bali, Principles of Mathematical Analysis by Older Rudin, Mathematical Analysis by S.C. Malik, Elements of Real Analysis by S. Narayanan M.D., Rai Singhania. You can refer these books. Thank you.